Happy New Year, everybody. The goal is to do math every day. Give me a follow, and I guarantee I'm going to get you to love mathematics. Let's go ahead. Let's do some math. All right, so here we have the integral of 1 all divided by x squared minus 2x plus 3 dx. Looking at this, how can we attack this? Well, the denominator here, we have a quadratic. A great strategy to try is going to be to complete the square. So how we can go ahead and complete the square on this quadratic is basically we can go ahead and think of it just equal to 0, and then we would go ahead and move the constant to the other side. So we'd have x squared minus 2x would now be equal, well, we have x squared minus 2x plus 3 equals 0. So moving the 3 to the other side, we have x squared minus 2x is now equal to negative 3. Now, why am I leaving a gap here? Well, to go ahead and complete the square, once we now have these two terms, we now want to add something to give us 3 terms that's going to then factor as something squared. And how we can do that is just first of all, make sure that the coefficient on x squared, so the number in front of x squared is 1. It is 1. There's nothing here. There really is a 1 here. Once that's 1, all we do is just take half of the coefficient on the linear term. So half of the number in front of x, well, the coefficient on x is negative 2. Half of negative 2 is, well, negative 1. But then we square that and we get, well, negative 1 times negative 1 is 1. So we're going to be adding 1. But we add something to one side of the equation, we better go ahead and add the same thing to both sides. So our equation is still equal. So we added 1 to this side. So we go ahead and we add 1 to this side as well. So now we have x squared minus 2x plus 1 is equal, well, is equal to negative 3 plus 1. But x squared minus 2x plus 1, that is going to factor as x minus 1 times x minus 1. So x minus 1 times x minus 1 is going to be x minus 1 quantity squared, and that is equal to negative 3 plus 1, so is equal to negative 2. So then we just bring the negative 2 back over. So we have x minus 1 squared plus 2. That is now actually vertex form of this parabola. That's how we go to vertex form, is by completing the square. But then we can go ahead and say that this original integral is now going to be equal to this integral, which is now the integral of, well, 1 over x minus 1 quantity squared plus 2 dx. Now, is that going to be any easier than this original integral? It might even look more hard or more scary. But then we just go ahead and we recall that if we ever have the integral of 1 over, our variable here is u, so 1 over u squared plus some constant squared, so 1 over u squared plus a squared du, that is always going to be equal to 1 over whatever a is, so 1 over a times the inverse tangent or the arctangent of u over a. But we have 1 over x minus 1 squared plus 2, well, 2 is just going to be the square root of 2 squared. So we can say that we have 1 over x minus 1 squared plus the square root of 2 squared. That is, again, in this form of the integral of 1 over u squared plus a squared, where a is the square root of 2. And what is u? Well, u is x minus 1, so therefore our integral is equal to, it's just equal to 1 over a, which is 1 over the square root of 2, times the inverse tangent of u over a, which is the inverse tangent of x minus 1 over the square root of 2. But 1 over square root of 2, nothing is wrong with 1 over square root of 2, but a lot of people, for some reason, they don't like to have a square root or a radical in the denominator. So all what we did here is multiplied by square root of 2 over square root of 2, which is just 1, so we're not changing it. So 1 over square root of 2 times square root of 2 over square root of 2 is going to be equal to square root of 2 over 2, right? Because square root of 2 times square root of 2 is 2. So therefore, this is equivalent, this is equal to the square root of 2 over 2 times the inverse tangent of x minus 1 over square root of 2. And of course, don't forget your plus C, the Don't forget your cheese. All right, calculator. Take care.